As we continue solving our rational equations, I want to run back through this last problem that we looked at yesterday, just to kind of remind you of the process, because we're headed towards some that are a little bit more complicated. We multiply through by the common denominator, which is has to have a factor represented from each denominator. So this one had a 2 and an x minus 3. We multiplied through by 2 and x minus 3. And I think I showed you yesterday where it's kind of handy to write the factors right next to each term in the equation, because it's easier to cancel and multiply. We don't have to worry about having things left over. We did it that way yesterday, and we'll continue doing it that way today. But when you multiply through, the denominators go away, and you're left with a nice, easy little linear equation that we can solve at -1. We have to remember at the outset of the problem, either based on the denominator or based on what we're multiplying by, it can't be 0. You can't multiply through an equation by 0, so from the start, x cannot be positive 3 in this problem, and x equals -1 is a good answer only because it's not 3. If you get 3 as an answer, it's not a good answer. You have to toss it, and the equation would have no solutions if that's the only one that you came up with. All right, so next one, let's move on. 1 over x plus 3 plus 2 over x minus 3 equals 15 over x squared minus 9. Sorry, Megan, I had a little. One over x plus 3 plus 2 over x minus 3 equals 15 over x squared minus 9. Now, to find the common denominator here, what do we need to do? What do we need to do? X minus 3, x plus 3 will do it. Why is that? Because x squared minus 9 is a difference of squares, and it can factor as x plus 3 times x minus 3. So we're going to multiply through the entire equation by x plus 3, x minus 3. You can show it like we've been showing it. I'm going to kind of come out here to the side, and I'm going to write x plus 3, x minus 3. Sorry, I'm getting in the way of that 1, but that 1 doesn't really matter, does it? X plus 3, x minus 3. And again, x plus 3, x minus 3. So we're multiplying each term in the equation by x plus 3 times x minus 3. In the first pair of terms, what cancels? All right, hold on, time out. What do we need to make a note of at this point? It's really easy to forget this. X cannot be plus or minus 3. We've got to remember that, because if we get one of those answers at the end of the problem, we got to stop. There's no solutions. Okay, x plus 3's can cancel. I'm left with, in the first term, 1 times x minus 3, which is just x minus 3. Bring that sign down, it's plus. Here the x minus 3's cancel. And I'm left with 2 times x plus 3, which is 2x plus 6. Here, x squared minus 9 is x plus 3 times x minus 3, so that whole factor is gone, and I'm just left with 15. All right, now we're just going to solve a very simple linear equation. X plus 2x is 3x. 3x plus 3 equals 15, because -3 plus 6 is positive 3, so we simplify. Subtract 3 and divide by 3, we get x equals 4. And that's a good answer because it's not plus or minus 3. I'm going to keep reminding you of that in hopes that you're hearing it and you're not going to miss the problems on the test because you put an answer that's not an answer. All right? Is everybody good with this? Okay, let's look at another one then. Try this next one on your own. See what you can do with this one. All right, so the first thing we do is factor the denominators, right? We need to factor the denominators to see what common factors are needed to get rid of all of the denominators. So this would be x plus 1, x minus 1, and the first denominator is 4 and x minus 1. Yes? So what do we need to multiply through this equation by to get rid of all the denominators? 4, x minus 1, and x plus 1 is correct. So I'm going to just write these kind of up here. 4x minus 1, x plus 1. 4, x minus 1, x plus 1. And here a 4, x minus 1, x plus 1. And right now we need to stop and make a note. X cannot be plus or minus 1. Cannot be plus or minus 1. If I get one of those answers, then I have to reject it. And that's going to come into play especially when we are working the ones that have quadratics that show up. We don't start with an x squared, but we end up with an x squared. We create extra answers, and often those extra answers are excluded. Not always, but often. So when we multiply the first one, the 4 and the x minus 1 cancel. I'm left with 5 times x plus 1, which is 5x plus 5. Right? Careful with the next one. Why do we have to be careful with the next one? Because I got a negative 3 hanging out here. The x minus 1s will cancel. And then I'm left with negative 12 times x plus 1, which is negative 12x minus 12. Some of you are reaching for your erasers, right? Got to remember that negative sign. There's a negative 3 there. The negative is going to distribute. Looks like about half of you are erasing. Got to be careful there. Does everybody understand where that negative comes from? It distributes through that parentheses. And in the last term, we have the x plus 1, x minus 1's canceling, and I'm left with 7 times 4, which is 28. All right, so 5x minus 12x is negative 7x minus 12 equals 28. Oh yeah, I said negative 7 and wrote negative 12. I don't know what the deal is. Or maybe I did, or maybe I didn't. I have to go back and check. Yes, 5 minus 12 is negative 7. I knew something wasn't looking right. Then we can add 7 to both sides, and we get negative 7x equals 35. I'm skipping a little bit of process here at the bottom because you guys can do this. Divide both sides by negative 7, and we get x equals negative 5. That's a good answer because it is not positive or negative 1. Okay, now it's kind of what's dangerous about these problems is that most of them are going to have good solutions, but then there's the 2 that slip in there that don't. You know, we're going to look at some of those in just a moment. All right, so let's move forward to the next example. What would we multiply by here?
X plus 2, x minus 2.
So y'all can see it quickly, right? X squared minus 4 is x plus 2x minus 2. Let's just watch this one click through. Okay, don't write it down. If you multiply through by x plus 2x minus 2, in the first term the x plus 2's cancel and we're left with 3 times x minus 2, which is 3x minus 6, right? When the next term the x minus 2's cancel and we're left with 2 times x plus 2, and then that's all going to be equal to 8. And what's not on this PowerPoint is what x cannot be. What can x not be in this particular equation? Positive or negative 2 are not options, right? Positive or negative 2, x cannot be. That's going to disappear when I do this, but when you distribute, you get that. When you add that, you get x equals 2. Okay? And then this thing kind of gives it away. Why is that not the answer? Because we just said a moment ago that x cannot be plus or minus 2, because if x is plus or minus 2, then we have zeros in all of these denominators, and we multiplied by a 0. You can't multiply through an equation by 0, so x cannot be 2, and this particular equation has what? No solutions. All right, so here's an example of where one can be really dangerous. It's easy to solve, right? There's no negatives to distribute. You're going to be really tempted to just run right through this, solve it, x equals 2, move to the next problem. But you have to hit those excluded values. Okay? No solutions. All right, this one's getting a little bit more involved. So let's have a look at this. For our next test purposes, we're kind of done. Our problems aren't going to go beyond what you just saw. Is everybody clear? But I want to give you a preview. Here we're giving you a preview of what's to come in tests around the corner. X plus 1 over x minus 3 equals 3, plus 6 over x squared minus 4x plus 3. What do we need to do? Factor the denominator, right? So I can see what factors are needed. And the factorization there is going to be x minus 3 times what? X minus 1. So I need to multiply every term by x minus 3, x minus 1. So when I multiply the first term by x minus 3, x minus 1, I'm going to cancel the x minus 3's, and I'm left with x plus 1, x minus 1, which is x squared minus 1. Now, we have a little gift here. This is x squared minus 4x plus 3. So I don't have to multiply it back out because I just factored it as that. So when I multiply the 3 by this, it's 3x squared minus 12x plus 9. Here these things cancel and I'm left with plus 6. Now what's different here? What's different here than the previous equations? There's an x squared, right? And it's not going away. X squared, we haven't reviewed how to solve quadratic equations. This is a second degree equation, so we're looking for how many answers? 2 answers, as long as one of the answers is not positive 3 or positive 1. Right? So what's the strategy for solving a quadratic equation? This is why this is not on the next test, because we haven't covered quadratics yet. What's the strategy for solving a quadratic equation from Algebra 2? We want to set it equal to 0. And we're either going to solve by factoring, completing the square, or the quadratic formula. Okay, so set it equal to 0, we would subtract x squared from both sides, add 1 from both sides, or to both sides, and that will give us 0 here. 2x squared minus 12x plus 16. Right? Now normally I would have to take out a GCF of 2, but because this is an equation, I can just divide everything by 2 and make the 2 go away. So I'd have 0 equals x squared minus 6x plus 8. And what's the factorization of x squared minus 6x plus 8? Anybody? Somebody? X minus 4, x minus 2. And if these two things equal 0, again, we're going to review this in much more detail before we do this again. We get x equals 4 or x equals 2, and those are both good answers because they are not equal to 3 or positive 1. All right, so when the quadratic problems start showing up, it gives us a little bit more tricky scenarios to deal with.